Click the bell icon to get latest videos from Ekeeda.
Hello friends, in today's video we are going to see few examples which are based on the circuit which is nothing but the base bias with emitter feedback. So let's begin with the topic. Base bias with emitter feedback circuit provides better stability than any of the circuit. So before moving towards the problem or actual examples, let's first have a look of some important formulas related to the circuit. So the first formula related to the circuit is collector current IC, and it is given by VCC upon RE plus RB upon beta. The second important formula, that is nothing but the base current, and it is equals to VCC upon RB plus beta into RE. VC sat is calculated by using VCC minus IC into RC plus RE. In order to find out or in order to obtain the Q point, we required VC sat. In order to draw the DC load line, we require VC sat and IC sat. And these values are calculated by using VC sat is equals to VCC and IC sat is equals to VCC upon RC plus RE. So these are the few important formulas that are used for obtaining various values of current and voltages in case of base bias with emitter feedback circuit. So now let's begin with the problem. The statement of first problem is calculate all the DC bias voltages and current if RB equals to 400 kilo ohms, RC equals to 2 kilo ohms, RE equals to 1 ohms, VCC equals to 20 volt and beta equals to 100. Neglect VBE. Now here we require to find out all DC bias voltages and current, that means base current, collector current and VCE. Just now we have saw the various formulas of collector current, base current and VC. So by using those formulas we are going to find out values of them. So first let's write down a given data. The statement of first problem is calculate all the DC bias voltages and current if RB equals to 400 kilo ohms, RC equals to 2 kilo ohms, RE equals to 1 kilo ohms, VCC equals to 20 volt and beta equals to 100. Neglect VBE. So in this case we require to find out all DC bias voltages and current, that means base current, collector current and VCE, that is collector to emitter voltage. They have given the different values of RB, RC, RE and VCC and beta. So first let's write down a given data. Here they have mentioned that we required to neglect the value of VBE. If it is not mentioned, then we require to assume the value of VBE as 0.7 volt because most of the time the transistor used in the circuit are silicon transistor. So first let's find out the value of IB. So the formula for IB is IB equals to VCC upon RB plus beta into RE. We have all the values of quantity, so let's substitute the values and find out value of IB. So after substituting the values, we obtain IB equals to 0.04 milliamperes. Now next thing is to find out the value of IC. The formula for IC is IC equals to VCC upon RE plus RB upon beta. So we have all the values, so let's substitute. So IC is obtained as 4 milliamperes. Now next is to find out value of VCE. The formula for VCE is VC equals to VCC minus IC into RC plus RE. So this is how we can find out the value of all the DC voltages and current if the values of RB, RC, RE is given. Now let's move to the next problem. The statement of second problem is if the circuit having RB equals to 240 kilo ohms, RC equals to 2.2 kilo ohms, VCC equals to 12 volt, beta is equals to 50, find out IC and VC. Also draw a DC load line and indicate Q point. VB is equals to 0.7 volt. In previous problem, VB value is not given and it is mentioned in the problem that neglect the value of VB. But in this case, the value of VB is given and that will affect the value of collector current. So let's first write down a given data. So first find out the value of IC. In previous problem, as the value of VBE is required to be neglected, therefore we have not considered it. But in this case it is given, so the formula for IC is VCC minus VB upon RE plus RB upon beta. So now let's substitute the values. In this problem, value of RE is not given, therefore we considered it as 0. So after solving the equation, we obtain IC equals to 2.35 milliamperes. Now next thing is to find out the value of VCE. So the formula for VCE is now get modified as the value of RE is not given. The formula was VCC minus IC into RE plus RC, but as the value of RE is equals to 0, the formula is get reduced to VCE is equals to VCC minus IC into RC. So the value of VC is 6.83 volts. So for drawing DC load line, we require VC sat and IC sat. So VC sat is approximately equals to VCC. So VC sat is obtained as 12 volt. Now next thing is to find out IC sat. The formula for IC sat is VCC upon RC. So IC sat is obtained as 5.45 milliamperes. So now let's draw the DC load line. So the DC load line is obtained by indicating the values of VC sat and IC sat. VC sat is obtained as 12 volt, IC sat is obtained as 5.45 milliampere, and Q point are nothing but the values that we have obtained as IC and VC. So IC is equals to 2.35 milliampere and VC is equals to 6.83 volt. So this is how we can draw the DC load line by using the value of IC sat and VC sat. So in this case, the value of RE is not given, so we consider it as 0, and we require to consider the value of VBE as it is mentioned in the problem. So now to understand the concept in more detail, let's move to the next problem. The statement of problem is, if CE circuit having VCC equals to 30 volt, RC equals to 5 kilo ohms, RB equals to 1.5 mega ohms and beta equals to 100, then draw DC load line and find out Q point. So in this case, we require to obtain Q point, that means IC and VC value, along with the DC load line which require VC sat and IC sat. So given data is, so first find out IC sat. So IC sat is obtained as 6 milliampere. Now VC sat is nothing but VCC only. So the second parameter, that is VCE sat, is equals to VCC. Therefore VCE sat is equals to, as VCC is 30 volt, so this is also 30 volt only. Now in the problem they have mentioned to find out Q point also. So for obtaining Q point, we require value of IC and VCE. So the value of IC is obtained as IC equals to beta into IB, and to obtain the value of IB we use the formula. So the value of IB is obtained as 20 microampere. So now let's find out IC, which is beta into IB. So the value of IC is 2 milliampere. Now next point is to find out another point of Q point, that is VCE. So VCE is obtained as VCC minus IC into RC. We consider it as 0 ohms only. So the value of VC is 20 volt. Now let's draw the DC load line and point out or mark Q point in that. So this is how we can draw a DC load line and Q point for given values of resistors and for obtaining various values of IC, VC, IC sat and VC sat. So this is what all about the problems based on base bias with emitter feedback circuit, which provides better stability than any of the circuit. So I hope you understand this topic. So thank you very much for watching this video. Stay tuned to Ekeeda, subscribe Ekeeda. Thank you.